Hello guys, welcome to another video. Today we are going to find the kth maximum and minimum element of an array. So basically in this question what we need to do is we need to find the kth maximum, means the second maximum, the third maximum, the fourth maximum, whatever the question asks. So these are two different questions. Either find the maximum or either find the minimum kth element. It will not come as find both the minimum and maximum. If it comes like this, the simple solution is sort the array out and count. Simple as that. So basically what the question says is we are given an array like this. It can be 1, 7, minus 11, 20, 16 and 19. For example, we are given an array like this. Now we need to find second largest element or second second maximum and second minimum. So the second maximum is 19 and the second minimum is 1. What you can do is in the brute force approach, we are gonna simply sort this array out. After sorting, it will be like minus 11, 1, 7, 16, 19, 20. After it is sorted, you just need to count the minimum and maximum. If it is the second maximum, here you are. If it's the second maximum, sorry, here you are, and it is the second minimum. Okay, you can get it like this, but this is not the optimal approach. It will take big O of n log n. So basically this is not the best optimal approach out there. So what can be the optimal approach? Let's see. Now we are going to look at the optimal approach. For optimal approach, you should need to have some experience or some knowledge of minimum heap, max heap, and heapify operation. If you don't know about this concept, you can, in the further videos, I am going to launch a DSA short-term course where you can learn about this, or you can just Google it and you will find what is min heap, what is max heap, and what is heapify operation. After you know all these concepts, you can look at this video and you will know how this problem is working. Now let's look at the approach, how this min heap, max heap, and heapify operation can help you solve this question in less time than n log n. So basically what we are going to do here is, let's say we have to find the kth maximum element. So we are gonna go with the max heap. I am repeating myself. If you have to find maximum, if you are finding maximum, go with max heap. If you are finding minimum, go with min heap. That is the case here. Okay, what is max heap and min heap? So basically the max heap concept is the root node should be greater than both the childs. Okay, so this is the left child, this is the right child, and this is the root node. So the root node should be greater and equal to. This should be greater and equal to both the left and right. This is the max heap concept. Okay, this is the only concept you need to know. And in an array, we represent this max heap with left left child is 2 into k plus 1 and right child is 2 into k plus 2, where k is the index of root. For example, let's see, this is the root node. Okay, so basically the left child should be 2 into k plus 1. 2 into 0 is 0, plus 1 is here. This is the left child. What is the right child? 2 into k, that is 0, plus 2, this. Okay, then what should be the left child of this when we take it as a root? 1. 2 into 1 plus 1, that is 3. You can see here that we are using that formula and we are getting left and right childs. Okay, now what we need to do is we need to solve this question and we need to find the maximum element here with the help of Heapify operation and max heap. How we are going to solve this? Let's look at the question right now. For solving this question, what we are going to do is we are going to do a Heapify operation on this. When we are doing a Heapify operation, this array will change into a max heap, and after this Heapify operation is completed, we can just simply take out the maximum element, which is always at the root node, and just check it out to the last. After I give an example, you will understand what I mean. Let's take an example. For example, we have an array here like this. We are taking a small example because it will consume a lot of time if we go into long numbers. 1, 7, and 9, and 10 basically. So when we construct a tree for this, it will be like 1, 7, 9, and 10. Okay, so the Heapify operation will start from this node because always the Heapify operation starts from n by 2 minus 1. Here n is 1, 2, 3, 4, 4. 4 divided by 2 is 2 minus 1, that is 1. That is the index. So here 0, 1. 1 index is 7. So we are gonna start our Heapify operation from here. When we do a Heapify operation, it will check if the nodes are in balance condition, means left node and right node is smaller than the root node. No, here left node is not smaller. Then we need to swap it. After we swap, this will become 7 and this will become 10. Okay, now it will check with the upper node because it is swapped. Is this maximum and minimum? No, we need to swap there also. So it will become 1 and it will become 10. Okay, now this will come here and this is already sorted. So nothing will here and we have our max heap. So the array will look like this: 10, 7, 9, and 7. Okay, 10, 1, sorry, 10, 1, 9, and 7. Okay, so after the max heap is completed, we will take this element and put it at last. Just listen and go with the example, and we will reduce n by 1. Okay, and we are also gonna reduce our k. For example, k is 2 by 1. Okay, that is great now. So it will become 1, and n, which is basically 4, that will become 3. After swapping, this will become 7 and this will become 10. Okay, now this part is separated out. We are not going to use that part. We are going to use the remaining array for doing that max heap operation. So basically we have now 7 1 9. Now we are going to do a max heap operation here. You can see this is not compatible. We need to swap it out. We are going to swap here and we are going to get a new array like this: 9 1 7, and this is the part we are not gonna do anything with. After that, we what we need to do is do a swap here with the last element of the array, new array. Okay, when we swap it out, it will look like this: 7 1 9 10. Now the n is your 3, and we already told you that we need to do it -1, and here also we need to do the counting, which was k will be 1 minus 1, it is 0. When your this becomes 0, what you need to do is you need to print the nth element. Simple as that. Here nth element is to second index, that is 0 1 2. This is your second maximum. Now you have got your answer. Let's look at the code, how we are going to do it in a code. So now let's do the coding. We are going to use Java. You can choose any language. Just follow the steps. So basically we have to do some operations here. First we are getting the nums array and the key, that is the element. First of all, we are gonna get the length of the array, which is nums.length. After we get the length, we need to perform that heapify operation. How many times? You guessed it correctly. N divided by -1. That is the start. We are gonna go from there to the 0th element. So we need to do a for loop for int I equal to n divided by 2 minus 1. I is greater than equal to 0, I plus plus. And we are gonna do a heapify operation here. And we are gonna pass the nums, that is the array, the index we wanna heapify, and the length of the array. We specifically need to pass the length, mean the last index of the array. So here what we have as the last index is n minus 1. It depends on you how you write the algorithm. You can pass the last element or you can pass the whole length. So we also can pass the whole length. We have passed the length, so it will just do the heapify operation again and again. It should be I minus minus because we are going in the backward direction. So it will create your max heap. Here you will have your max heap. After you get your max heap, what you need to do is you need to do the operation for how many times. You can use a for loop or a while loop. We can use a for loop from int I equal to 0 till I less than k, because we need to do k operations, I plus plus. After this, we need to do heapify operations how many times? I times. We will start from I equal to 1. Now what we need to do here is we need to swap this out. First we need to swap the places of a of 0 with n minus 1. So we are going to create a swap function which will be swapping out the array's position of 0 and n minus 1, the positions. Okay, after we swap out, we are gonna do a heapify operation, and this heapify operation will only go to the, it will start from the 0 index, because heapify operation is starting at the first index only. We have only changed the uppermost index, nothing else is changed, so we are not gonna change anything. And we are gonna pass the length which is n minus 1 basically. We can do n minus I here, so it will swap and it will do this again and again. We are gonna just change it to n minus I, so basically it will swap out every time. And after all these operations are completed, we are gonna return the last index, basically if k is 2. So this will do 2 operations, and after that the last second element is your kth second maximum element basically. So we are gonna do nums n minus k. Simple as that. Now we need to provide that heapify operation. Now that heapify operation is like this. Just follow the intuition and write the code. It will be a private method. It will be repeated again, so think about it carefully. It will be not returning anything, so it will be a void operation, private void heapify. It will take an integer array, that is basically nums. It will take the point from where it has to compare, that is the root node, so we are gonna write the root. And it will take the length, so basically n. So basically after we have all these things, we need to perform that heapify operation. How we are going to perform that heapify operation? I have already told you that we have to find that left and the right index, and after that we have to perform, we have to check if the left and right index is in the position or not. So basically what we need to do here is we need to create a largest in largest that is our root node. Basically we just assume that root is the largest, and after that we need to find the int left and right. The left will be root into 2 plus 1, and the right part is root into 2 plus 2. This is how we are going to get left and right. After we get the left and right, we need to check if left, that is basically we have left is less than n. It should be less than n. If it is equal to or greater than n, then we know that the boundary is crossed. The array is no more. It will give you out of bound error. So this will be the first check, and the second check is if nums of left is greater than nums of largest. If it is largest, if it is verifying both the condition, what we need to do is we are gonna just simple as that. Second condition is also the same. Just we need to do here is right. We are comparing from right now, so we will just replace it with right. If it is the largest element is smaller than right, then we need to replace it with right. Now the most important condition comes here. If you already know, if there is no swapping out in this part, meaning if the largest is not changed, it is already the root, then there is no heapify operation here, so we need to do nothing. That's why we are gonna check if largest not equal to what I say, not equal to root. If it is not equal to root, then we don't need to do anything. That's why this is the first check. If it is not equal to root, what we need to do is we need to perform that heapify operation again, and that heapify operation will contain nums. It will also contain it will be done from the largest element, because that is the one that we have changed right now. And again, right, what we need to send here is the size of the array. Before we perform that heapify operation again, we need to swap this two elements out. So we are gonna send nums, we are gonna send largest, and we are gonna send root, so that we can swap these both elements out. Now we also need to create a swap operation. See, we have also used swap here, we are also swapping here. We can use it both the ways from one function. That's why I always take it as a function for simplicity purposes. We need to create a swap function where we are getting an array of int nums, int of I, int of j, and we are gonna see temp nums of I. Swapping is simple, you already know the code. Just simply swap the functions. And remember, whenever you are in an interview, talk to the interviewer what you are thinking. Like I am telling you, just we need to swap this out. You need to tell what you are thinking, what understands what you are trying to do, and help you out if you are doing something wrong. Okay, so looks like our code is completed. Let's do a dry run. Okay, it looks fine. This is the Heapify operation. You can see the code here. It is a swap operation, and we are creating a max heap first, and we are doing the operations k number of times, so that we can find the kth maximum element, and the so basically the timing for this is L log k. It is better than L log n. That's why it is the optimal approach. We are gonna just submit this code. You can see it is passed correctly. Let's meet in the next video. Thank you.